Let Z be normally distributed with mean 0, standard deviation 1. Find the probability that Z is between 0.3 and 2.5. So as with the last example, our random variable Z has a standard normal distribution because the mean is 0 and standard deviation is 1. We want to find the probability that Z is between 0.3 and 2.5. So let's draw it out. We have a bell curve with mean 0. And since we want to find the probability that Z is between 0.3 and 2.5, we want to find the area under the curve between 0.3 and 2.5. So let's sketch out that region. So 0.3 is quite close to 0. Okay. So 0.3, let's say it's right there. And then 2.5, that's much further away. So we want this region here. Okay. Now, we need to be careful here because R can't calculate directly the probability of a normal distribution between two values. So what we need to do is we need to use some kind of trickery. Our strategy here, okay, our strategy is going to be to get the normal distribution we want, we are going to draw that a little better. There we go. We're going to calculate everything to the left of 2.5 to start with. Okay, so 2.5 is way over here. We're calculating everything to the left of 2.5 to start with. But notice that's going to give us too much, right? We want just everything between 0.3 and 2.5. This is everything to the left of 2.5. We don't want all this stuff over here, right? So if 0.3 is right here, we don't actually want this region, right? But so in order to get rid of that, we need to subtract the bit that we don't want. We need to subtract the bit that we don't want. So that bit is the bit that's to the left of 0.3. So we are going to subtract the probability of being to the left of 0.3. So there's 0.3. That's the bit that we don't want. So in other words, we calculate everything to the left of 2.5, everything to the left of 2.5, and then subtract off the bit that we don't want, which is the bit that's left of 0.3. We don't want anything over here to the left of 0.3. We want just what's in between 0.3 and 2.5. So mathematically, this means we're going to take the probability that Z is less than 2.5 and subtract off the probability that Z is less than 0.3, which is the part that we don't want. Okay? So that's our strategy. So now that we understand what we're doing, we can go to our notebook and calculate it. Okay? So probability, P norm, and we want everything to the left of 2.5 first. So since it's to the left, that's where we're including the lower tail, so lower tail true. Okay? But then we want to subtract off the extra bit that we don't want. We don't want anything to the left of 0.3. And since it's to the left, the lower tail is also true. Okay? So everything to the left of 2.5, and then subtract off the extra bit, which is everything to the left of 0.3. And so we get this probability, which means the probability that Z is between 0.3 and 2.5 is 0.3759. So there is about a 37.59% chance that a randomly chosen z-value will lie between z equals 0.3 and z equals 2.5. Okay, so let's finish it off by, let's copy this value and let's put it into our actual solution box. Submit, and we have it.